back to my channel Tutelage, a guide to learner. Here, this is Sriparna. Hope all of you are doing well. Today, we are going to start a new session with some new topics of measures of dispersion. We have already discussed some topics of this chapter. So, that's why today's session is called Measures of Dispersion Part 5. Okay, so if you have missed my previous session, please go and check it once. I hope it will really help you. Okay, previous session link is in my first comment and my description box. Okay, so learner, let's move on to the next slide. Here we can see some topics for today's discussion. Okay, so first one, that is calculation of the mean deviation and the standard deviation. We have already told what do you mean by a mean deviation and standard deviation, and what is the basic differences between mean deviation and the standard deviation. So today we will discuss the calculation process or estimating process of the mean deviation and standard deviation both. Okay, so now move on to the second concept, that is merits or advantage of the standard deviation, and third one is demerits or disadvantage of standard deviation. So learner, let's begin the session and move on to the next slide. So here this is the slide of measures of dispersion. So we can see measures of dispersion is of two types. The first one is absolute measures and second one is relative measures. So some measures of dispersion is under the absolute one, okay, and some are under the relative one. So now going to the next slide where we can see some measures of dispersion. So they are basically range, quartile deviation, mean deviation and the standard deviation. So today we are going to start a new session with the basically calculation process of the mean deviation and the standard deviation. So move on to the next slide and the main slide. So here this is a slide of the mean deviation. This is a slide for the definition of the mean deviation. We have already told what do you mean by a mean deviation, but before going to the estimation process or the calculation process of mean deviation, so at first we have to know what do you mean by a mean deviation. So basically mean deviation is the arithmetic average of the deviation of the observed values from an average of these observed values. So now going to the formula. So I think it will be very easier when we are using the formula. Okay, so here we can see the formula. We can see summation x minus x bar. Okay, so x minus x bar. So x bar means arithmetic mean and x is the observed values. So now going to the previous slide, we can see in the definition deviation of the observed values from an average of these observed values. So that means x minus x bar. Okay, and the average. So how do we calculate the average? Always x bar equals to summation x by n. Okay, so that's why x minus x bar summation x minus x bar divided by n. So that's why this is the formula of the mean deviation. So mean deviation is the arithmetic average of the deviation of the observed values from an average of these observed values. I think this is clear. So now move on to the main slide for this session. Okay, so this is the calculation process and the problem is in continuous series. Okay, so the problem is calculate the mean deviation of the following series. There is two column two row and 1 2 3 4 5 columns. So class, interval and frequency. So there are four classes basically, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and frequencies are 3, 4, 2 and 1. So now going to the solution for this problem. So here this is the step for solving the problem. Okay, so the first step, that is estimate the arithmetic mean, that means x bar. Okay, so what is the formula of the x bar? That is summation x by n. This is the formula of the x bar. Clear? Now going to the second step, take deviation of the class marks from the arithmetic mean and consider only the absolute values. We have already told mean deviation is always taking only the absolute values, okay, without considering any algebraic sign, that is plus or minus. So we always consider only the absolute values in the calculation of the mean deviation. Okay, so take the deviation of the class marks from the arithmetic mean and consider only the absolute values, that means without algebraic sign, that is plus or minus. Okay, now going to the third step, each deviation is multiplied by corresponding frequency and sum of their multipliers is obtained. Okay, and fourth step is calculate the mean of the deviation by the formula, and formula is summation fd divided by summation f. So with frequency we have already known with frequency the total number of observation, that is total frequency. So summation f is equals to the total frequency, and which is denoted by the capital N, not the small n. Okay, and this is the mod value. Mod value means it doesn't consider the algebraic sign plus or minus, and we have already told mean deviation in the calculation of the mean deviation we always consider only the absolute values without the algebraic sign. So D indicates the deviation of the values, and summation fd, that means f into d. In the third step we have already told each deviation, so that means d is multiplied by the corresponding frequency. So frequency, f indicates basically frequency, so that's why f into d, and sum of the multiples is obtained, so that means summation fd. Okay, so now going to the next slide. So here this is the solution for above mentioned problem. So we can see there are 1, 2, 3, 4, 5, 6, 6 column. First column indicates the class interval. Second column indicates frequency of the class interval. Third column indicates midpoint. Fourth is fx, and fifth is deviation. Observed values, deviation the observed values from the arithmetic mean of the average of the observed values. Okay, and now going to the sixth column, here we can see f into d. Okay, so we know there are 4 classes, 2 to 4, 4 to 6, 6 to 8 and 8 to 10. So frequency is 3, 4, 2 and 1. So total frequency, that means capital N, which is equals to 10. Okay, and now going to the calculation of the midpoint. Okay, so 2 to 4. Clear? So when we are calculating midpoint of the class interval in the continuous series, we always take only and this is the calculation process, basically lower class plus upper class divided by 2. So that means for first class interval, 2 is the lower class and 4 is the upper class. So 2 plus 4, which is divided by 2 because there is 2 class boundary. Okay, so 2 plus 4, that means 6, 6 by 2, which is equals to 3. So the midpoint for class midpoint for the first class, this is 3. Now going to the second class, 4 to 6, that means the same process, 4 plus 6 divided by 2, that means 10 by 5, which is equals to 5. And now going to the third class midpoint is 7, and now going to the fourth class class midpoint is 9. Clear? Because 8 plus 10 which is equals to 18, 18 by 2 which is equals to 9. Basically, standard deviation is a measure of average of deviation from the average. Okay, the average chosen in this case is the arithmetic mean, but since the sum of the deviation from the arithmetic mean is always 0, and this is one of the main property of the arithmetic mean. Okay, so basically sum of the deviation from the arithmetic mean is always 0. So that's why standard deviation is calculated by taking the squares of the deviation. Okay, so that is the basic differences between the mean deviation and the standard deviation, because in the case of mean deviation absolute values of the deviation are taken, but in the case of standard deviation squares of the deviations are taken. Clear? So I think this is clear because we have already told what do you mean by a standard deviation. So now we are going to move another slide for the estimation or the calculation process of the standard deviation. So now move on to the next slide. So here this is the formula of the standard deviation. For the first formula for without frequency series, sigma, this is called sigma, and this is the sign of sigma, and which is denoted basically standard deviation is denoted by sign sigma. Okay, so the first formula, the root over summation x minus x bar whole square divided by n. Okay, so only the small n, not the capital N, because there is no frequency. So now going to the next formula with frequency series, sigma is equals to root over summation fd square divided by n minus summation fd by n whole square. Okay, so now going to the calculation or the estimation process of the standard deviation, and which is one of the most commonly and widely used measures of absolute measure of dispersion. So now let's move on to the next slide. So here this is the estimation or the calculation process of the standard deviation, and this problem is in individual series. So basically we can see here calculate the standard deviation of the following series, and this is the series. And now going to the next slide where we can see some step for solving the problem. So the first step, we have to take any value as an assumed mean. Okay, and capital A, assumed mean is denoted by capital A. Now going to the second step, calculate the deviation of the items from the assumed mean, that means x minus A, which is called D. D means deviation. Now going to the third one, squares the deviation and denote the total summation D square. And now going to the last step, applying the formula of the standard deviation. Okay, so now move on to the solution. So here we can see there are three columns. The first column indicates marks, second column indicates the deviation, and third column indicates the square of the deviation. So at first we have to calculate the assumed mean. So in the even number series we have to take only 4th and 5th class marks. Okay, so here we take the 5th class marks. Okay, so that's why here for this problem the assumed mean, which is denoted by capital A, which is equals to 46. So now going to the second column for the calculation of the deviation from the assumed mean. So for the first class, 40 minus 46, which is equals to minus 6. Here we can see minus 6 because uh, mean deviation consider only the absolute values, but the standard deviation consider the algebraic sign of the values. Yeah, basically it takes the original values and with considering uh, algebraic sign, plus or minus. So that's why 40 minus 46, which is equals to minus 6. Okay. Now going to the second class, 40 minus 46, which is equals to minus 4. 38 minus 46, which is equals to minus 8. 44 minus 46, which is equals to 2. For here we can see for the fifth class, 46 minus 46, which is equals to 0. For the seventh class, for the sixth, 1 2 3 4 5 6 7. Okay. Okay. So for the next class, 48 minus 46, this is that 2, and 50 minus 46, that means 4. So the total is minus 14. And now going to the last class for indicates the squares of the deviation, that means minus 6, squares of the minus 6, that means 36, 16, 64, 4, 0, 4 and 16, and total is 140. And the formula of the standard deviation, that is sigma, is equals to root over summation d square divided by small n. Okay. So there is no frequency, so that's why cap small n is equals to 7. And now going to the second part, that is summation d by n whole square. Okay. So that is small n, summation d means minus 14, so minus 14 by 7, so which that means minus 2, so minus 2 whole square, that means 4. Okay. So root over 20 minus 4, that means root over 16, so that's why 4 is the correct answer for this particular problem. So now going to the formula of the standard deviation. Here we get small n equals to 7 because there is no frequency. And now going to the formula, root over minus summation d square by n. So d square means 140, 140 by n, that means 140 by 7, which is equals to 20, and summation d by n, that means 14 by 7, which is equals to 2, 2 whole square of the 2, that means 4. So root over 20 minus 4, which is equals to 16. So root over 16, that means 4. So 4 is the correct answer for this particular problem. Okay, so I think this is clear. So now move on to the next slide. So today we have only discussed the calculation process of the continuous series, but in my next session we will explain the calculation process of the discrete series. Okay, so now move on to the next slide, where we can see some merits and demerits of the standard deviation. So at first we have to uh, explain advantage or merits of the standard deviation. So the first point, that is standard deviation is capable of algebraic treatment. So we know standard deviation is the most satisfactory and the widely used measure of absolute measure of dispersion because of the following reasons. Okay, so that's why it is capable of further algebraic treatment. That means if standard deviation of the two pairs of the same data are available, so the standard deviation of the whole series can be calculated. So that's why it is capable of algebraic treatment. Now going to the second point, rigidly defined measure of dispersion. Okay. Standard deviation has sampling stability and it is a rigidly defined or precisely defined measure of dispersion. Now move on to the third one. It is not affected by much sampling fluctuations. We have already told it has sampling stability. So that's why it is not affected by it is not affected much by sampling fluctuations. And now going to the fourth merit, it is based on the all observation of the series. Okay. And now move on to the last one. Standard deviation is a significant measure which is used in sampling distribution, correlation, and the regression analysis. So, we know already standard deviation is used basically where the sampling distribution, correlation, and the regression analysis. I think this is clear. So now move on to the some demerits of the standard deviation. Basically, standard deviation is very difficult to understand and calculate because we are taking the squares of the deviation. Okay, so that's why it is little bit difficult to understand and for the calculation process. Okay, and now move on to the next one. So that is, it gives more weightage to extreme values and less to those which are nearer the mean. So it gives more weightage to the extreme values. Okay, so there is a differences for giving weightage. For there are two types of values in the series. First, there are extreme values and the nearer values. Okay, মানে which values are nearer to the mean. Okay, so standard deviation basically gives more weightage, more power to the extreme values. Basically, we already told, we have already told standard deviation is based on the all observations. So that's why standard deviation gives more weightage to the extreme values and less weightage to those which are nearer to the mean. So that is the basic demerits or disadvantage of the standard deviation. I think standard deviations, merits and demerits of the standard deviations is clear to everyone. So learner, we are done for the today's session. We have discussed some topic of the measures of dispersion, that is calculation process of the mean deviation and standard deviation, and merits and demerits of the standard deviation. I hope it will be very helpful to everyone. So I will come again with an exciting session. So till then, stay tuned and please do like, share and comment, and please do some support and subscribe to my channel. You can press the bell button for getting notification from my side. Happy learning. Thank you.